Today, I want to show you more examples about the chain rule. Take a review. The chain rule has two formulas. One is with only one intermediate variable. The other is with multiple intermediate variables. Here is the formula for one intermediate variable. If y depends on u and u depends on x, then y depends on x. Therefore, y is a function of x. The chain rule says that the derivative of this function is equal to the derivative of this function times the derivative of this function. dy dx means derivative of this function. dy du is the derivative of this function. And du dx is the derivative of this function. The chain rule is easy to remember. If we cancel du from the denominator and from the numerator, then this is the left side of this equation. The formula with multiple intermediate variables. If y depends on u, u depends on w, w depends on v, v depends on s, and s depends on x, then y depends on x. Y is a function of x. This formula says that the derivative of this function is equal to the product of the derivatives of all these functions. This formula is easy to remember. If we cancel du, cancel dw, cancel dv, and cancel ds, then this product is reduced to only dy over dx. We often use the product rule, the quotient rule, and the chain rule. Here is a guideline to use them. A, when a function is a product, use the product rule to compute the derivative of the function. B, when a function is a quotient, use the quotient rule to compute the derivative. C, when you want to simplify a function, use the chain rule. Now, examples. Example 1, find the derivative of function f, where function f is this function. This function is a power function. The power is 4, and the base is cosine of 7x to the third. About this example, there are two solutions. In solution 1, I use the chain rule with a single intermediate variable to compute the derivative. In this solution, I apply the chain rule twice to get the result. In solution 2, I use the chain rule with multiple intermediate variables to compute the derivative. This time, in solution 2, I apply the chain rule only once to get the result. Solution 1, take derivative on function f, then plug in this function in function f to get this equation. Because this power function is complicated, I want to simplify the function. I let u below the base cosine of 7x to the third. Then the power function becomes very simple, just u to the fourth. Now we need to compute this derivative. Because u and x are different, before we can compute this derivative, we need the chain rule. Insert du to the denominator and put a du on the numerator. This is a product of two derivatives. The first derivative is the derivative on u to the fourth with respect to u. By formula, it is 4 times u to the third. Now, remove the intermediate variable u. Plug in cosine of 7x to the third in u. Then we have this equation. This is not the answer yet because we still need to compute this derivative. To find this derivative, I need the chain rule again. I simplify the function by introducing an intermediate variable w. I let w below x 7x to the third. Then the function becomes cosine of w. Now, I want to compute this derivative by this formula. But this formula requires all the variables are the same variable. In this derivative, x and w are different variables. To overcome the difficulty, I use the chain rule. I insert dw to the denominator and put 1 dw on the numerator. Derivative of cosine of w with respect to w by this formula is negative sine of w. Now, plug in 7x to the third in the w here. Then I have this equation. Move the constant 7 outside this derivative, then I have this equation. Derivative on x to the third with respect to x is 3x squared. Simplify this expression, then this is the result of this derivative. Now, plug in the result here, then we get the derivative of function f is this. Solution 2. In this second solution, I want to use the chain rule with multiple intermediate variables to compute the derivative of function f. For the purpose, I split function f into several simple functions. Y is u to the fourth. U is cosine of w, and w is 7x to the third. If we plug in 7x to the third in the w here, then we have cosine of 7x to the third. Plug in cosine of 7x to the third in the u here, then we get back to the given function. So the given function is a composite function of these three functions. Now, by the chain rule, dy dx, derivative of y with respect to x. This is the derivative of this function. is equal to dy du, derivative on this function. It is 4u to the third times du dw, the derivative on this function. It is negative sign of w, times dw dx, the derivative on this function. It is 21x squared. Now, in this expression, we remove u and w. First, remove u. Plug in cosine of w in u, then we have this equation. Then, plug in 7x to the third in the w here. Then we have this equation. Simplify this expression, then this is the derivative of function f. Example 2. Differentiate this function. Please note that this function is a product of two functions. The first function is 2x plus 1 to the fifth, and the second function is x to the third minus x plus 1 to the fourth. Because the function is a product of two functions, to compute the derivative of this function, we need to use the product formula. By the product formula, the derivative of function y is the derivative of the first function times the second function plus the first function times the derivative of the second function. Now we have this derivative and this derivative to compute. Let me compute them here. After I get the results, I put the results back to the expression. To find this derivative, we can expand the power, then compute the derivative. But expanding the power 5 is tedious. So I prefer to use the chain rule to compute this derivative. I simplify the function by introducing an intermediate variable u. I let u below 2x plus 1. Then the function becomes u to the fifth. Now, to compute this derivative, we need the chain rule. Insert du to the bottom and du to the top. This is a product of two derivatives. The first derivative is derivative on u to the fifth with respect to u. The answer is 5 times u to the fourth. Plug in 2x plus 1 in the u here, then we have this equation. Now, derivative on 2x plus 1 with respect to x is 2 times 1 plus 0. This is 2. 2 times 5 is 10. So this is the result of this derivative. Similarly, we compute this derivative by the chain rule, not by expanding the power. Let u below the base, x to the third minus x plus 1. Then this power function becomes u to the fourth. To find this derivative, we need the chain rule. Insert du to the bottom and du to the top. Then this derivative is equal to this derivative times this derivative. The first derivative is the derivative of u to the fourth with respect to u. It is 4 times u to the third. Now, plug in this polynomial in the u here, then we have this equation. Then compute this derivative. The result is this. Now, simplify this expression, then this is the answer of this derivative. Now, plug in this result in this derivative and this result in this derivative. Then the derivative of function y is this polynomial. Example 3. Given the table about function f, function g, derivative of f, and derivative of g, then use this table to answer these 4 questions. Question A. If R is this function, find the derivative of R at point 2. To answer this question, I first compute the derivative of R at the point x, because all the derivative formulas are about derivatives at the point x. After I get the derivative of R at the point x, then I plug in 2 in x to get the derivative of R at the point 2. Now, take derivative on function R. Then plug in this function in R. I have this equation. To find this derivative, I want to use the chain rule. I let u below the base f minus g. Then this power function becomes u to the third. To find this derivative, I apply the chain rule. I insert du to the denominator and a du to the numerator. Then this derivative is equal to this derivative times this derivative. The first derivative is 3 times u squared by this formula. U, this variable, is an intermediate variable. Now, I want to delete u. I plug in f minus g in the u here. Then I have this equation. To compute this derivative, I apply the difference rule. This derivative is derivative of function f minus derivative of function g. Now, this expression is the derivative of the function R at the point x. To find the derivative at the point 2, plug in 2 in the x here. Then we have this equation. Now, from the table, function value of f at 2 is number 3. Function value of g at 2 is number 4. And derivative of f at 2 is 4. Derivative of g at 2 is 7. So plug in the data in this expression, then we get derivative of arrow at the point 2 is -9. Question B. If S is this function is f of g of x, a composite function of the function f and the function g. Find derivative of function s at the point 2. I compute the derivative by the chain rule. I let u denote g of x. Then f of g of x becomes f of u. In this derivative, u and x are different, so I cannot compute this derivative. To overcome the difficulty, I insert du to the denominator and put a du on the numerator. Then this derivative is equal to this derivative times this derivative. This step is the chain rule. In the first derivative on function f of u with respect to u. In other notation, this derivative is f prime of u. Now, remove u by plugging g of x, then we have this equation. Derivative on g of x with respect to x in other notation is g prime of x. This is the result of the derivative of s at the point x. Now, plug in 2 in the x here, then we have this equation. From the given table, the function value of g at the point 2 is 4. So we have this equation. From the table again, derivative of f at the point 4 is -3. Derivative of g at the point 2 is 7. Therefore, derivative of the function s at the point 2 is -21. Question C. If w is g of f of x, this is a composite function of the function g and the function f. Find the derivative of w at the point 2. Because the function is a composite function, g of f of x. I compute the derivative by the chain rule. I let u denote f of x. Then this function becomes g of u. In this derivative, x and u are different. I cannot compute this derivative. To overcome the difficulty, I insert du to the denominator and du to the numerator. Then this derivative is equal to this derivative times this derivative. This step is the chain rule. Derivative on g of u with respect to u in other notation is g prime of u. Now, remove u by plugging f of x. Then we have this equation. Derivative on the function f with respect to x in other notation is f prime of x. Then this is the result of the derivative of function w. Now, plug in 2 in the x here, then we have this equation. From the given table, the function value of f at point 2 is 3. So we have this equation. From the table, again, the derivative of g at point 3 is 3. The derivative of f at point 2 is 4. So 3 times 4 is 12. Derivative of function w at the point 2 is 12. Question D. If v is f over g, find the derivative of function v at point 2. Because the function v is a quotient, f over g. This time, I compute the derivative by the quotient formula. By the quotient formula, I have this equation. Now, plug in the number 2 in the x here, then I have this equation. From the given table, derivative of f at point 2 is 4. G at point 2 is 4. F at point 2 is 3. And the derivative of g at point 2 is 7. G at point 2 is 4. So this number is the derivative of v at point 2. Example 4. Differentiate this function. This function is a composite function. It combines the square root and f times g together. To find the derivative of this function, I use the chain rule. I let u below f times g. Then this function becomes simple, just square root of u. Because in this derivative, u and x are different, I cannot compute this derivative directly. To overcome the difficulty, I insert du to the denominator and a du to the numerator. Then this derivative is equal to this derivative times this derivative. The derivative of square root of u with respect to u is 1 over 2 times square root of u. The detail is here. Now, remove u by plugging f times g. Then I have this equation. Now, I still need to compute this derivative. The function in this derivative is a product, function f times function g. So I apply the product formula to compute this derivative. Then I have this equation. This is the answer to this example, derivative of y. Example 5. Find an equation of the tangent line to the graph of this function at this point. To help myself answer the question, I arbitrarily draw a curve and suppose this curve is the graph of this function. Suppose this point is here and the corresponding point on the graph is this point. This point, x coordinate is square root of pi over 2. Y coordinate is the function value at x coordinate. Plug in this number in x, then the y value is 1. Function value is 1. Now, at this point, there is a tangent line. We need to write down the equation of this tangent line. To write down the equation of this tangent line, we need to know the slope of the tangent line. To find the slope of the tangent line, we compute the derivative on the given function. The given function is psi of x squared. It is a composite function, not a product, not psi times x squared. So to compute the derivative of this function, we need to use the chain rule, not the product rule. Now, compute the derivative by the chain rule. Set u to be x squared, then the function becomes psi of u. Because in this derivative, x and u are different, we cannot compute the derivative directly. Before we can compute it, we need to write it as a product of these two derivatives. The derivative of psi of u with respect to u by this formula is cosine of u. Now, remove u by plugging x squared. Then we have this equation. Derivative of x squared with respect to x is 2x. Then this is the result of the derivative of the given function. And also this is the slope of the tangent line to the graph at the point x. Now we can tell the slope of this tangent line. Plug in this number, plug in this point in the x here. Then the slope of the tangent line at this point is 0. We have the slope of the tangent line, and also we know one point on the tangent line. By the point slope formula, the equation of this tangent line is y minus y1. y1 is the y coordinate of this point. It is 1. It's equal to the slope. Slope is 0 times x minus x1. x1 is the x coordinate of this point. Now simplify this equation, then we get y is equal to 1. The graph of this equation is a horizontal line.